the semiconductor industries. Our panelists today are Michael Smith here at Intergraph Houston office and Matthew Sims at Intergraph UK. A quick reminder before we start, all attendees are muted by default, so if you have any questions, please type them in the questions tab. And with that, Michael, over to you.
Thank you, Alex, and good morning, everyone, or good evening, or good afternoon, whatever time of the day it may be where you are. We'll just proceed here and move forward. What I want to do is start the webinar with a brief discussion about how we're speaking to other industries or alternative industries other than oil and gas where you can succeed with CADWorx. And briefly, those industries involve semiconductor, pharmaceutical, the food and beverage industry, and water treatment as well for drinking water, wastewater, or desalination. And of course, naturally, we have the obvious connection with CADWorx from the oil and gas industry for downstream petrochemical or even power industry as well. But we're going to focus on the pharmaceutical and food and beverage industry regarding our sanitary specification. And with that said, I just want to bring some brief statistics to the meeting, and I bring your attention to the last paragraph where 90% of the companies in the food and beverage industry anticipate an increase in sales in 2016. With that said, 81% anticipate an increase in net profits. The median increase would be roughly 10%, with an average expected increase of some 17% for a net profit projection of increase by 10% as a median, but perhaps an average increase of 15%. So the indication here is that we have a profitable industry. Here's some additional statistics about some of the top performers in the food and beverage industry. Note that the statistical data is always lagging 1 year behind, and we'll see the 2016 statistics show up by spring of 2017. But you can see some of the names that are quite prominent in the food and beverage industry, Nestle being one that we'll talk about. Bringing your attention to, say, North America food and beverage, you can see some of the statistics for countries.
Hey, Michael?
Yes?
Looks like your screen is turned off.
Is it showing now?
No, we're good.
Huh, that's interesting. Well, let me just back up one screen then, because what we're going to talk about is some of these companies in the food and beverage industry, and I wanted to bring some statistics to the meeting. And you can see a very sizable amount of revenue from, say, a company like Nestle or PepsiCo, but Anheuser-Busch, Coca-Cola, these are names that I think we're all familiar with. And then the chart on the right is really reflecting capital spending. So they are making large revenues and investing in themselves as well, but any of the companies that service them are looking for performance advantages, and that's really the message today, is that CADWorx is a performer advantage for any of the consumers of our software and using it in these industries to perform plant design. North American beverage companies, Kraft, some of the others, Nestle, PepsiCo, just some additional graphics to represent their revenues. Over in Europe, we have a similar scenario. Here again, look at Nestle at the top, Anheuser-Busch. And so this is just for our colleagues in Europe that might be viewing to see that, in the food and beverage industry, we have various companies that are leading in various markets, such as, multiple products or, beer, dairy, any number of other categories of food and beverage within that industry. Some percentage in terms of increased exports. Same thing for Europe. There's a pretty sizable increase in any one category based upon this kind of data here. Now, with that said, at Intergraph, we understand that our CADWorx plant professional software must meet the demands of our customers in the food and beverage industry. And some of those customers, as an example, is Nestle, Miller Brewing, Kraft Foods, to name just a few. And when we talk about this, we really are talking about a plant inside of a building, as we show here, the Nestle plant in Bakersfield, California. The challenge is that we have a plant design, but it must be held within a building which is intended to maintain a clean environment. With that said, that same plant, the Nestle's brand ice cream plant, is the world's largest ice cream plant. And in that regards, for the dairy industry, it's quite a success story. And one of our clients, the Dennis Group, has been involved with this client for some time. And we thank the Dennis Group for their success and performance with our software since the early days of adopting the Sanitary specification. Another success is with Briggs & Burton in Staffordshire, UK, where they utilize CADWorx for the food and beverage, pharmaceutical, and health and beauty market as well. And as you can see by this quote, they leverage the database, which results in cost savings from fixed prices with their suppliers because they were able to maximize the discounts by ordering in bulk based upon the model. So some really good performance there. Here's another example in the wine industry in California where CADWorx is utilized to develop their 3D models for wineries, and that application of sanitary piping as well. So moving on to the pharmaceutical industry as an example, the global pharmaceutical market is worth some $300 billion a year, a figure expected to rise to $400 billion within 3 years. And the 10 largest drug companies control over 1/3 of that market, several with sales over $10 billion a year and profits in 30% range. But if we look at revenues, and now in this graphic, we see that it's a very lucrative industry, obviously. And some additional statistics which I bring to your attention is that an estimated 3 billion euros in capital expenditures currently going into the ground in construction. We have companies, currently upgrading and expanding their facilities, such as Pfizer or Bristol Myers Squibb. Projected range for these projects are anywhere from 75 to 700 million euros, and will take between 3 to 5 years. So it's a very lucrative, active industry, and I think we all would agree that we have to eat, we need medicine, we have to drink water. So these alternative industries are growing and will continue to grow over time. So they're very prominent and lucrative industries to be involved with. Some additional statistics, and I bring your attention to the top line, revenue worldwide pharmaceutical market, but then the bottom line projects that spending in medicines by the year 2020 will increase by some 50%. And so those statistics mean that there will always be work in these industries. Here's an example of CADWorx at work in a pharmaceutical project in China. As you can see, CADWorx was used for the piping vessels. PB Elite was also involved there as well, and we see some examples of that. So there are some examples of some really great projects. But here again, notice that everything is contained within some kind of building structure. Moving on to actually talk about the sanitary plant specification. As we all know, it involves stainless steel tubing and some very unique multi-port valves, as we see here in this image. Know that we understand that the pharmaceutical and food and beverage industries have unique stainless steel piping systems, valves, and vessel requirements, and we deliver software tools to address your industry needs. As we see here, a very unique valve matrix, lots of clamped fittings, and unique vessel representations. As we know, sanitary piping is really utilized in the pharmaceutical, food, beverage, and dairy industries. And as you can see there on the right, a very unique stainless steel environment, very clean environment. Why is that? Well, we have clamped connections which are designed to allow piping systems to be installed easily and then disconnected quickly to modify piping systems between production runs. And as you see there, we have the ferrule, the clamp, the gasket, and the other ferrule. And these ferrule connections and clamp connections are unique to this industry. And so our specification has to support that requirement. Obviously, there's another requirement for slope piping to eliminate bacteria entrapment areas. So all systems have to drain. And then we need to support these unique multi-port valves, as you see there in the lower right. Going down the checklist, all process piping and clean in place or CIP piping in plants consist of sanitary stainless steel fittings, valves, and pumps, as you see there on the right. Sanitary fittings are polished stainless steel tubing fittings that have to meet certain industry regulations, such as in the case of the U.S., we have the USDA and the FDA regulations that must be met. Obviously, there can be no cracks or crevices or surfaces, including the gaskets that could hold bacteria. We're supporting the 304 and 316L stainless steel, which is required for the cleanliness or hence the hygienic reasons. And we support the butt weld and clamp type fittings as well. A little history. In this case, Jim Lin was one of the original authors that worked with us to develop a sanitary spec. So I pay some credit to Jim to have helped us. And that history involved, Jim was looking for something in the sanitary industry back in the late 1990s. And Vernon Walker, who knew him, played a key role in having Jim team up with what we were then called COAID to help develop the sanitary spec. By 1998, that spec had been developed and was working in an AutoCAD environment and supporting the migration from 2D drafting, 2D design to 3D modeling. So in this case, Intergraph, CADWorx and Analysis Solutions, had led the way some 18 years ago to move forward with the sanitary specification in support of the pharmaceutical and food and beverage industry. With that said, I teamed up with Jim again in 2014 to move that legacy sanitary spec forward, update it, and make it work within our current software capabilities. And that's really what we're here to talk about today. And with that said, that was published as a content pack for our existing customers and for those of you who may be looking at CADWorx and considering it for your applications of sanitary plant design. We had a content pack published in February of this year. Now, with that said, that sanitary spec involved migrating a lot of historic data forward into our current software and evaluating various manufacturers of multi-port valves such as Waukesha, Tugendhagen, Alfa Laval, Sugmo, Swagelok, and currently I am in discussions with ITT. And with that said, that specification, when we look at it in the spec editor, as you can see, it contains the necessary long description information to provide you accurate deliverables and bill of materials for purchase purposes or constructability. So with that said, let's move to the CADWorx 2017 version of our software, where we are very excited about showing these very accurate tri-clamp representations, as you see here on the screen. And that involved enhancing our in-type support for clamped conditions or grouped pipe conditions. As you can see, we focused very strongly on the types of clamped conditions that may be required in your plant design, but the routing enhancements and gasket associations or bolt associations have been addressed. And then we have a piping rule that allows you to turn on and off a very accurate 3D representation of the clamped condition, which allows you to control when and if you see this representation, and then this will be shown to assist you in clash detection value as well. The same thing is true with some other clamped conditions. In this case, in the Victaulic representation, we have a very accurate representation for grooved piping as well, and here you see an example of the ISO representation for that condition. And then another representation of the triclover or clamped conditions, whatever it may be. The ISO Gen S key is representing the appropriate coupling, and if it's a ferrule connection, then the ferrule is also showing up as well. So we've moved forward with an improved or enhanced capability clean across the board for these clamped and coupled conditions. And as you can see, the multi-port valves also support all of that representation, which then allows you to, like any other valve, pick on the valve, the plus sign, and begin to auto-route BPE tubing right from the valves. Right, so now what I'd like to do is actually show a very brief video, just so you can see this in action, but then we'll go to a live demo in the software that follows. But just to give you a very quick look at it, as to how we are auto-routing just like any other CADWorx components. But in this case, it is the Sanitary specification, and all of the components are available in the right-click mode as you're accustomed to with the CADWorx products that we sell to the oil and gas industry. We're very excited to share with you today that all of this is working fine for the Sanitary spec. And so I'll just progress along. As you can see, we're easily auto-routing and very productive, intuitive workflow with the spec as it is. I'll move forward in the video to show you again that all of this information is available through the component or CADWorx component edit dialog. But now let's go to the ISO so you can see that. And we'll see this again live here in just a few minutes when we go to a demo. And so we'll generate some ISOs and take a look at that result. Some of these bill of materials spills onto the second page, but now we look at the representation of the multi-port valves, the ferrules, the clamps, all the information that is clearly represented in the ISO now. And of course, the associated bill of material information is called out quite clearly. As you can see, the tri-clamp with the wing nut and the ferrule, etc. All right, so with that said, I'll move on to the next screen, and obviously the clamped and ferrule condition is well represented as we now show here again. Right, so one final note is, we're continually seeing success with our software. And in this case, I wanted to share a recent success just this month in China, where the customer chose our software over a number of competitive products, as you see there in the third bullet on the right. We're very excited that customers keep choosing our software because of the obvious values of ease of implementation and flexibility to integrate, and the scalability of our software to meet their needs, whatever those challenges might be. Right, so here's another example of what I was talking about earlier, is that obviously this is a plant inside of a building. So this is a representation of a pharmaceutical plant where the owner required BIM, or Building Information Modeling. And this is a good segue to talk about our recent updates to the CADWorx Design Review 2017 software, where we have a new export capability to meet BIM standards and deliverable requirements in those projects. That being that we can create a IFC file. I'll explain that in the next slide. But this enables you a new level of deliverables, enabling you to comply with project requirements, satisfy owner requirements for BIM implementation. This improves your collaboration with other stakeholders by sharing the data. It passes data-rich content, and that in turn serves downstream needs of facilities, operations, and maintenance. What we are talking about is the fact that most of these projects have some kind of architectural software creating the 3D building. That might be Revit, that might be Graphisoft ArchiCAD, or some other product. But the whole requirement for interoperability is paramount in meeting BIM standards, and those BIM data exchange standards require a specific data exchange format, that being an IFC file. That standard for industry foundation classes is something we're very excited to share with you that is new in CADWorx Design Review and enables you to meet those BIM deliverables of IFC files and exchange your data with other stakeholders such as Revit users. So what does that interoperability workflow look like? It's very straightforward. Take your CADWorx 3D piping model, open it up in CADWorx Design Review, and export the necessary IFC file. That in turn can be read by Revit. An import of the IFC file brings the CADWorx 3D piping model directly into a Revit building. And in turn, the intelligence has been passed through. The data-rich content of our CADWorx model is now present and visible. And so you've been able to share your 3D CADWorx model inside of a Revit building model. And with that said, I think it's time for us to go to a poll question, isn't it, Alex?
Yes, it is. Everyone, we have a few poll questions for you today. First one, going up on your screen right now. If you could please take a few moments to vote. Which industry do you consider your primary market? Pharmaceutical, food and beverage, water treatment, or semiconductor, or other? We'll take just a few moments for this question. Okay, it looks like the majority has voted. We'll go ahead and close this one out and share the results with you. Okay, and I believe up next we have Matthew, who's going to guide us to through the demo. Matthew, I'm switching over to you.
Thank you, Alex. Hello, everybody. Can everybody see my screen?
Not yet.
Not yet.
Now?
Right, there you are.
Good, brilliant. Okay, on the screen we have an example of a CADWorx model of a part of a pharmaceutical plant. So if I zoom in slightly, let me see a little better. So I'm just going to unload a little bit of this model here just so we can see what I'm about to demonstrate. Let's just jump round. So if I open up the specification editor, we can see the Sanitary specification that Michael referred to earlier on. And so this is our standard BPM or BPE for you guys. And also within here we have various valve specifications as well. So I'm going to zoom in down here and let's start routing with this tubing and various components. So let's pull away from this ferrule here. So use the exact same line number, and we see we have the two tubing options that we have within our spec. So I'm going to come out 2 meters, and then I'm going to use the auto routing to connect to the nozzle on the bottom of this CIP tank. So we get our 2 routing options. So I'm going to use the yellow route, and we have the option to add a fastener component to the nozzle. So I'm going to select a clamp, and we should see the clamp there, and also then a ferrule. I'm going to choose that line, and now I'm just going to go jump to 2D wireframe, and let's have a quick look at that nozzle. So we can see that we have placed the gasket, ferrule and clamp all associated with that connection. Same at this end here as well. So if I just hover over each of the components, we can see that the long description that Michael referred to earlier on, which contains the type of the steel material. Also, we'll notice that it contains the polish as well, which is quite important in this industry and this specification. And that happens to be on all the components. So we have the same for the clamp, and then let's be a little bit tricky here, but see if I can grab the gasket. Yep, and the gasket too. So let's go back to our realistic mode. And then let's come around and look at this CIP line that runs behind these tanks at the back here. Now we can see we already have some multi-port valves already placed on the line, so let's add another. So let's switch, and I'll use the alpha valve specs. And as we can see, we have quite an extensive specification here. So lots of different types of valves. I'm going to grab this one from our spec. And as we can see, we've grabbed our valve, and just before I place it, as we're all aware that we use piping rules within CADWorx to help automate and make placing components and routing a lot easier and more efficient, and that's exactly what I'm going to do here. I'm going to fully utilize them. So before I insert it, we can see that we can cycle through all the various connection points on each of the ports of this valve. So that's the one I want, and let's place it on this line. Like any other inline item, I can move it along the line. I can also change the justification. So there we have it, it's to the middle of the valve, and we're going to place it in the middle of this pipe. And then I get the option of which direction do I want the top port to face, and we'll place it there. So I'm going to keep the specification because the line we're currently on is the BPM, but the valve is on a slightly different specification, so I'll keep that. And here we have the rules coming into play. So it recognises that it's a ferrule connected clamp pipe. So we'll select ferrule, and I see I made a mistake. Let's place it on. Nice, okay, yep. I thought I'd left it the wrong size, but again I've got my rules set up just so that it doesn't matter, it's changed the size. So I'm just going to close that down for now. And we notice we have just plain clamps, and now before earlier in Michael's pictures we saw we have a graphics overlay for these clamps. So if I run a command, we can see those very same clamps here. So they are all set within your specification. So if I open up the spec editor, we can see our spec available here, and look at the couplings, which is the clamp here. Look at the data table in the catalog, and we can see the directory where the DWGs are saved, and also the DWG itself. So each one is assigned to a particular size clamp. That also can be
right, Matt, and obviously, you know, this really enhances the accuracy of the representation. You know, granted, you would turn these on and off on a selected basis, maybe for a presentation, but the key here, the value that it brings, I think, is the next part you're going to show, and that's class detection, right?
Yes, exactly. So I'm going to switch to a top view to show this a little better. I'm just going to change those back to the visual style that we saw before. I'm going to copy this line and just move it over slightly. That should be enough. So we can see at the moment nothing's clashing in this view. There's a bit of a gap between the clamps and the valves as well. In fact, the valves are pointed the wrong way, so once they're in place they can always be moved. So I'm facing that way. And now let's turn our clash detection on, just to show that there's definitely no clashes there. Nothing's coming up in a list, everything's happy. But we know that the clamps are much bigger than what they're currently being represented, so let's show those clamps again. And we can see there's definitely going to be a clash there between those two. So if I refresh my palette, we should see this clash show up in the list here, which it has. So, as Michael alluded to just a few moments ago, this overlay is really helps with clash detection and increased accuracy. So let's move this aside. Clash is now gone, issue resolved. We also saw in that video, we can pull away from the clamps, from the valve, sorry. And once we finish routing, again, CADWorx picks up that it's a clamped connection, so we add the relevant ferrule, and it's added the clamp and the gasket as well. So let's see all the clamps on here. I'm just going to rotate this one. So then it's in a position that's much easier to place and service, so in case this valve needs to be taken apart or replaced. So next thing to see is how this is represented on an ISO. So let's run oxygen. On that line we just created. Let's see if we can see if it'll run this time. Let's try running this bit of light pipe instead. Yes, there we go. So as we can see, we have a multi-port valve in the middle, we have our clamped connections there and there. We even see where there's a change in spec, the pipe's BPM, but the valve that we placed is from our alpha air valve spec. And also at the top here, we have our accurate material list, including our long descriptions and material type and polish. So I come back to our model. Let's quickly export a bill of materials to show that as well. Here we can see exactly the same list. So we have our valve, we have our 2 ferrules, 2 clamps, 2 gaskets, and also roughly 1.9 meters of tubing as well. So the next thing that we want to show you is routing sloped pipe. So to do that, I'm just going to bring in some more equipment and some more piping. So let's just attach that drawing and insert some more piping. So we see we have some piping already started at the top here for this vessel. I'm going to route from there down and finish on this pump here. But we need this piping or this tubing to be sloped. So all I'm going to do is use our line view palette just to isolate that line and the equipment. So let's use a plus grip and pull away. Select the tubing that we want. So I'm going to come up 450 mil and then select the elbow that I want to use from the specification. And now this is where I want to start my slope piping. So I'm going to use S, or I could pick from the bottom on the command line to start the slope piping. And I want to, it wants to raise by per meter, and I want to run 10 mil per meter. So first part needs to be 400 mil long, then 7 meters, 1.3 meters, and then 6.5 meters down. And let's just quickly switch views, and we can see that we are sloping in both directions. So let's finish this off. That's going to be the end of my slope piping, so I'm just going to press enter again to come out of the slope command. And again, I'm going to pick an elbow from my list. And then I'm going to use the auto routing capability of CADWorx to finish off onto the pump, just as we did before. So I'm going to choose the red line, and again we have the option of adding a fastener component, so I'll add a clamp and then a ferrule. I won't like to select again. So you can see it's finished off with the same connections as before. So we'll produce an isometric of this, and just before I do, it's quite a long line, so I'm just going to add a stop sign in of where I'd like to break the line, and then we're going to run an isometric. And before I run the style, I'm going to quickly jump in to iConfigure and make one change to my style. So you can see we have under dimensions, skews and falls. Let's maximize our window. And you can see we have quite a wide range of ways of displaying the falls on our isometrics. So I'm going to choose the ratio, save exit, let's come out of here and run isogen out. Produce two files. As we see from before, we have our clamp connections, also clamp connections on our nozzle, and you see it's calling out the nozzle and also the vessel it's attached to. Again, the same accurate material list, and then let's look at the other file it's produced. Here we can see our falls are all shown 1 in 100. and we also have the connection onto the discharge nozzle on the pump at the bottom. And again, our same accurate material list. And that is all.
Brilliant. Wonderful job. Good job there, Matt. So I think we've covered some of the highlights here with regards to our limited time. We're going to have another poll question, I believe.
Yes, everyone, we have one more poll question for you today, going up on your screen right now. Do you see CADWorx 2017 being a benefit to your industry? Yes or no? This is a follow-up question to the first one. And again, I would like to remind everyone, if you do have any questions, please type them in the questions tab. We will get to those during the Q&A. Okay, it looks like the majority has voted. We'll go ahead and close this question out and share the results with you. No surprises there. Okay, and we'll go ahead and go to our Q&A session now. Looks like we'll have a couple questions here. The first one, can you turn on all the realistic representations of the clamps? How large does it make the model?
Right, let me respond to that. Obviously, there is a piping rule now in 2017 that speaks to this issue, where you can show it selectively, show it always, or not show it at all. So there's a piping rule that enables you to work with a simple clamp representation, as we showed today, more of a cylinder representation, so as to allow you to quickly route your piping but maintain performance. But whenever needed, as Matt showed you, you type in the convert enhanced command, and those representations, those very accurate representations, will show up. I think the follow-on question is that how does that impact our file? Well, anytime we have additional geometry that is associated with a piping component, and we turn that on, it will be present in the file. I think the key part is to understand that when it is not in convert enhanced mode, or we've converted it back to solid, our performance is optimized while we're routing, while we're taking the design process forward. And so, yes, there is an expected file size implication, but I think the important thing is to represent that we have accurate clash detection, which historically has been a problem with representing these very unique clamped conditions. So it's one of the workflows that you have to balance representation with file size and optimized performance. And I think that, as we showed, we can turn this on and off selectively and continue to work in a very productive way by not impacting our overall model. In the end, the model can be quite large, but that's also another discussion about model management. And so I hope this answers the question that it is an option to turn it on and off on a selective basis. But just bear in mind that, as we try to improve accuracy, there can be a file size implication. I hope that answers the question.
Yeah, Michael, this is Dominic. I just wanted to add one comment to that, and thanks for that explanation. I just want to add that we do keep in mind that, of course, the higher the level of detail you have in your models, the bigger your drawing size is going to be. And what we've done to control, to the extent possible, the size implications of these more detailed components is that all these clamps that you saw in the demo by Matthew, all these clamps, they are actually using what's called a block reference under the hood, which means if you have a 4-inch line that's got the same clamp 100 times on that line, that drawing's file size is not going to increase by 100 times that block size. It's only going to increase by 1 time that block size, and all 100 instances in the model are going to be referencing that same single reference of the block. So we've done what we can on our part to try to make sure that even with high details, the drawing size is been limited as much as possible.
Yeah, thanks, Dom. I think that's a nice additional clarification, and I'm sure everyone is appreciating the fact that we're not replicating that same block impact over and over again.
Okay, it looks like we have one more quick question for you today. I realize we're going way over on time here, but does everything you showed come with a